rational, well, I guess we're not talking about rational expressions, because we've been talking about rational expressions, simplifying rational expressions. But today, we are going to be working with rational equations. Now, what is the difference between an expression and an equation? It has an equal sign. You all are exactly right. So I'm going to have what I have up here equals x minus 6 over 3x. So the thing is here, we have the ability to simplify this and solve this for x because it's an equation and not an expression. So we want to simplify it. We want to get things much less complex than they are now. Do any of you have an idea how we might be able to do that? No. Well, so Madison had an idea of basic factoring. That could be a good route to go. Let's think about that. But here's the big thing. Right now in this equation, we have some of these that are whole numbers, not fractions. Some of these that are fractions, and it equals things that are fractions. Justin. What? Well, yeah, boy. You're saying, could we add this 1 into 24? That's a good question. Let me pose it to you guys. You all cut it out, please. This is Nate, Keegan, and Elijah's fault. So, can we add this 1 into the negative 24? Why can we not? It's not a fraction, it's not in the same terms. Now what I mean when I say it's not in the same terms is this 1, if it was written as a fraction, would be 1 over 1, right? But, Holly, I'm going to mention that in just a moment. It's written as 1 over 1, right? So the thing is, if it's written 1 over 1, can it add to something else that is not over 1? They have to have the same denominator to be able to combine. So what's going to happen is we need to write this in terms of the same denominator. So if we have 1 over 1, how do you think we could rewrite this number to match this denominator? Yeah, so Don Ann said we could multiply it by 3x. That's absolutely right. A moment ago, Holly said that as a shortcut to that, anytime you have 1 over 1, you can write it in terms of the denominator. So if you ever heard of 1, you can look at the other denominator and write that denominator over itself. 3x over 3x. This is how we can write a 1. We can write a 1 as the other denominator. So, yeah, we just know if we see a 1, we can write it as this denominator over itself. That's a shortcut to it. Because if we did multiply it by 3x, it would still be 1 over 1 times 3x over 3x, right? So 3x, 3x, same thing. This is just kind of a shortcut. Now here's another, even better shortcut to these problems. You notice that every single part of this problem has a denominator of what right now? 3x. When every single part of a problem has the same denominator, what'd you say? Cancel them out. They can go away. So if you have made it to where every part of the problem has the same denominator, they are all going to go away, get canceled out, and be removed. Meaning we can actually write this as 3x plus x squared minus 5x minus 24 equals x plus, or x minus, my bad, x minus 6. So we've now taken it to where we had 3 different fractions in this problem to no fractions. Because all the denominators were the same, so that denominator gets to cancel out across the board. At this point, we can what? Combine like terms. So in terms of x squareds, how many x squareds do we have? Just 1, x squared. What else?
And then you can add the 3 to the negative 5 and get negative 2x.
3x negative 5x makes negative 2x, and then minus 24, right? That equals x minus 6. What do you think we should do?
Basic factoring.
Well, okay, so Justin's got something interesting, because I heard basic factoring, which is definitely something we can consider. But I think a better idea is actually to get all of our numbers, all of our whole numbers, all of our variables on one side right now. So if I move this 6 over here, I move this x over here. Yes, Layla?
Just a second.
Okay. So effectively what we're going to do is we're going to get all of our whole numbers combined, all of our variables combined. So I'm going to add this 6 to the other side. Add this over here. I'm going to subtract this x to the other side. Subtract this x over here, right? X squared, negative 2x minus x minus 3x, and then negative 24 plus 6, negative 18. What is that going to equal? 0, because we cancel all this out, it equals 0. Now is when we want to do that basic factor. Now that we have everything by itself, or this whole polynomial equals 0, that's when we want to get our basic factoring involved. So if we want to basic factor this, we need factors of what number?
Negative 18.
Negative 18. That add up to?
Negative 3.
Negative 3. What are factors of negative 18 that add to negative 3? Negative 6, positive 3. Spot on. So my two factors are going to be x minus 6, x plus 3. Now if this equals 0, how do you think we can figure out what x is when we have two things multiplying? Well, if we FOIL it, what's going to happen? We're going to come right back to where we were. Here's the thing. All we have to do, we separate them and we set them each equal to 0. X minus 6 equals 0. X plus 3 equals 0. Add 6. Add 6. X equals 6. Subtract 3. X equals negative 3. And we end up with two answers. And yes, we can just flip the signs if it's a binomial that just says x plus or minus something. So we have our answer of 6 and negative 3. So if we went back to the original equation and plugged either of those in for x, we would get an equivalent answer on both sides. So effectively, we have 3 steps here. We have our first step. Make the denominators match, then cancel them out. Our second step is combine like terms and get the equation to equal 0. Third step is basic factoring and set each binomial to 0 to solve for x. All right.
Step 2 is
Combine like terms and set it equal to 0. I'll write them on the board here. So our first step is make the denominators match. Match. And then cancel them out. Step 2 is combine like terms. And we're combining like terms to the point where the equation equals 0. And then our third step is basic factor. And as part of that, you set each... Nate, Elijah.
What?
Set each binomial equal to 0 and solve.
Do you like this picture?
So we have, it's wonderful, Elijah. So we make the denominators match, cancel them out, combine like terms so the equation equals 0, and then basic factor it to set each binomial equal to 0 and solve. Now in all reality, not all of these are going to require basic factoring if we don't have an x squared, if we don't have a polynomial in here. We could be looking at a problem that just has a totally normal, just 2x plus 5. Then there's nothing to factor at that point. So let me write a second problem on the board for us. problem is r plus 5 r plus 5 over r squared minus 2r minus 1 equals 1 over r squared minus 2r. Alright. So, if this is our problem, what is the first thing you think we should do here? Make the 1 match the rest. Now, how do we make a 1 match the rest of the equation?
Put it r squared minus 2r over r squared minus 2r.
Exactly. R squared minus 2r over r squared minus 2r. We are writing it, as I like to say, in terms of the denominator right here, right? In terms of the other denominator. So now that all the denominators match, what may we do? Cancel them out. They can all go away. These are all going to cancel. And I am left with r plus 5 minus r squared minus 2r equals 1. Why do you think I wrote r squared minus 2r right here in parentheses? That's exactly right. We have to notice, right here, we substituted that in for the 1, right? But we were subtracting the entire 1, meaning we're subtracting this entire unit. So what does that minus sign do? It distributes. It distributes to everything in there, exactly as Holly said. This minus sign is going to effectively distribute into both parts of what we substituted into the equation, making this actually read r plus 5, a negative times a positive r squared, minus r squared, and a negative times a negative 2r actually being plus 2r equals 1. So you always have to remember, if you are substituting something in, and you have a negative in front of it, you must distribute that negative to everything you substituted in.
Flip the sign.
Yeah, flip the signs effectively. So, at this point, we can move on to step 2, combine like terms. Do we have any terms to combine?
The r and 2r.
R and 2r. So we are going to have negative r squared plus 3r plus 5 equals 1. Now what? Subtract 1. Thank you, Justin. Subtract 1, subtract 1. So we're going to end up with negative r squared plus 3r plus 4 equals 0. Have you all ever factored a problem that had a negative in front of the x squared, r squared, whatever it may be? Well, it would be, but we can't have that negative r squared. So what do you think we do about that?
Flip all the signs.
We must flip every sign involved. We have to flip every sign involved. So if you ever run into a negative in front of an r squared, you must flip all the signs. Meaning r squared becomes positive. Then we write minus 3r minus 4 equals 0. You can't really flip the sign on 0. Now when we basic factor it, we're looking for factors of what number?
Negative 4 times negative 3.
Negative 4 that add to negative 3. As you all said, negative 4 and positive 1. Meaning our factors are going to be x minus 4, x plus 1. If we set each of those equal to 0, x minus 4 equals 0, x plus 1 equals 0. What are we going to find as our two values for x?
Positive 4, negative 1.
Positive 4, negative 1. Spot on. And those are going to be our two answers. X minus 4, x Or x is negative, sorry, x is positive 4, x is negative 1. All right. I'm going to stop there. We're going to do another example, and then we're going to do another one. Don't forget, it's not written on the board. Always say goodbye.